We wrote about criteria queries as well, right? Okay. So next one is, let's create a package. Inheritance. See, you remember, like you guys understand inheritance concept, right? So I'm not going to. So let's say we take the car example. So we'll have what attributes here? Number of wheels, and steering, something like that. These two are fixed in the car. But if you extend this car, let's say BMW car and next Tesla. So those two features will be there for BMW. Along with that, third feature is engine type, right? This one also having engine type. Brand name. So this is the association. How do you store these values in the database? Right? Now you create a car and BMW extends car, Tesla extends car, and you want to store these details in the database. How do you store the data? How do you store these details in the database? That is where inheritance comes into picture, like inheritance concepts comes into picture in Hibernate. What does it is? So the collection mapping in this one, basically using, how do you map it? Using the ORM relations inheritance. Okay, is a relationship. One is like a, let's say you have simple, we'll say take car, which is having two attributes, and extending by BMW, which is having additional two attributes. Okay, how do you want to persist these two objects? How do you want to persist this data into the database? This inheritance, how do you want to persist into that? There are different options you have. Okay, one is table per class. So we have two classes. So table per class. One is create a car class, create a BMW class. Okay, and have the car reference ID, two attributes, 1, 2, BMW ID, 1, 2, here car ID. So foreign key relationship, table per class scenario. Okay, and another option that we have is table per subclass. How many subclass we have, so many, those many tables you create. And another option we have is table per concrete class. So I'll explain you guys one more time. Let's say we have a car object. We have two attributes. Okay, we have BMW. We have two more attributes. One or three different ways you can save into the database. Three different ways you can save this data into the database. One option is table per class option. In table per class, you take entire thing as a unit and store it into the database. Like how many? Here we have two, here we have two, total four, right? So total four columns, something like that. Okay, so how many car details you can put? Another option is table per subclass. You have, let's say you have one more subclass called Tesla, which is extending on two attributes. Here how many you create? You create two tables. One is BMW table, another one is Tesla table. BMW table is going to have two attributes, 1, 2, and car attributes also will be have B1, B2, car 1, car 2. Here what happens? T1, Tesla 1, Tesla 2 attribute, car 1, car 2 attribute, something like that. Another option is table per concrete class. Third option is table per concrete class. So this is one class, this is one class. Create car table first, create Tesla table, create BMW table. Three tables, separate tables. Table per concrete class. In table per concrete class, if you have 1, 2, 3 concrete classes, you create three tables. If table per subclass, you have two subclasses, create two tables and inject all the parent details into each car. Table per class is keep everything into single table. Okay, let me take you another example that we did earlier as well. Let me write. It's simple. First time if you see it, it will confuse, but it's not that complex. Okay, then I'll take a concept called payment method. Okay, payment. Yeah, just payment or payment. Yes, it works. Payment works. So just payment. In that payment, there is a. This is the one super class for me. Okay, I have one is private payment ID, private string amount. Payment ID. What happened? Sorry, I'm idiot. Int. Okay. Then public payment. That is dummy class. Where I want to inject data is another one, public payment int payment ID int payment ID string amount. Okay, this is another constructor we are writing. This dot payment ID equal to payment ID, this dot amount equal to amount. Okay, that helps me to insert the data quickly. That's the reason. Okay, source, setters and getters. Okay, so I'll create, this is the payment class which is having payment ID and amount. Okay, so what kind of payment you are going to do? There you may have bunch of options, right? One is you can do it by payment card, credit card. You can do it by check. You can do it by debit card. You can do it by cash, right? You can do it by mobile payments. You have n number of options, right? So I'm going to take two different options. Okay, one is credit card, another one is check payment. Okay, credit card payment. This one is extending what? Extending what? Extends my payment class. So any credit card or debit card check, that should be with amount, right? Amount is the criteria, amount will be there. So that's the reason I kept it amount in super class payment. Now credit card payment. So in credit card payment, what will be there? CC number and CVV, right? You need to provide CC number and CVV. I'm just taking two values so that it saves some time. You can add as many secure details as you want. Okay, CC number, private, sing, CC, credit card, CVV. Okay, same thing. And we need a constructor, right? Another constructor and CC number, string, CC, CC number equal to CC number Okay, this is the what you call credit card payment. Credit card payment is extending payment, which means now credit card payment is having CC number, credit card CVV and amount, because amount is coming from payment card, right? You agreed? So that is the super class and a car and BMW, right? So next one, I'm just going to take class check number, or else check payment, not number, right? You should not call check payment. Okay. So check payment is going to what? Check number and check by, right? So private string say CQUV check number, private string CQ check by. Who is the person, right? Same shit. Let me copy paste it. Saves. sources, generators and setters. Okay. Nice. So now you got a payment as a superclass and two subclasses which are extending payment, extends payment. Okay. Now you want to store these details into the database. So what you need to do, first thing, you need to write your client call, right? Client class. So inheritance demo, keep that way. Inheritance demo, we have typical classes. Let me save some time for me. What you need to do, configure it, configuration, cfg equal to new configuration, configure, process your configuration file, session factory, then open the session, transaction. Okay. Okay, nice. Now here you need to call session dot transaction dot commit s dot close sf dot close. Okay, nice. Yeah, this one looks good. Our next challenge is writing our mapping file, Hibernate mapping file, right? So let's do it. Logic we will start writing here. First we will write our XML file. So like I mentioned, we have three different options, right? Table per class, table per subclass, table per concrete class. What I'm going to do, payments, table per class. Okay, so I need this stuff as is. I'm just going to take that. Table per class. Okay, so now we got a table per class scenario, right? HBM file. Oh, sorry, I need to configure at what, so that you can readable. And right also it will work, but dot HBM. Here Hibernate mapping. Here is our interesting challenges, right? So we have three classes. How do you map into the configuration file? So first payment superclass, let's write it. Payment class, right? Class. In this class section, inside class everything is going to be, and so you're going to have name equal to, we are writing table per class, com dot bell info dot, let me copy path, dot payment. Okay, so I'll call the table name as payment. Okay, then schema, schema schema. What is our schema? HIB schema, right? Schema. Okay. Next thing is you need to have an ID. I'm going to say payment card ID is my ID auto generator. Okay. So ID is name is payment card payment ID. Column you can give whatever the name you want, right? Payment ID. Payment ID. And what kind of auto generation I want? Generator. You can use anything. I'm going to say this time earlier I tried native, right? Increment. Okay. Okay. So this ID generation is done. Now what are the what you called? What are the different columns that we have? Amount we have. So we're going to write amount. Property name, sorry, property name equal to amount, column equal to amount. Okay, so this is our payment table. This is our payment table. Okay, but our goal is to save a payment. If it is check payment, you need to save check payment. You need to save, if it is credit card payment, you need to save the credit card payment. As we are writing table per class, so we want all the three classes: check class, credit card class, and what else? Check class, credit card class, and payment class. All the three classes in a single table. So you're representing a super class, and then inside you are writing all your subclasses. How do you write subclasses? Subclass. This is a subclass section. So where you're going to mention name. What is your subclass? One subclass is credit card payment subclass. Okay, name. I'll tell you. Okay, how do you map it? I'm intentionally skipping one value. I'll add it later. Property and one more property. Okay, first property is what? CC number, CC CVV. CVV. Right, column name is credit card underscore CVV, CVLUML column, credit card underscore number. Okay. Okay. So this is one subclass we wrote. Okay, nice. Another subclass we need to write, right? What is that subclass? Check payment. Check payment is what having? Check number, check by. Check by. So here you can say CHEQUE, check number, CHEQUE, check by. Okay, nice. So you are trying to say here The way you are trying to save the data is table per class. Let me explain to you. The goal is here you have a table called, you are going to create a table called payment card. Okay, you are going to create a table called a payment table. Okay, in this payment table you're going to have what? Payment ID, let's say like this. Okay, amount, and then credit card number, CVV, check by, check number, ID will be there. But there will be one more column which will needed to identify whether it is by credit card, whether it is by check. See, if you keep saying right now, if you try to save pay by credit card, you're going to fill these four details. These two details going to be empty. And if you're going to pay by check, these fields will be filled. These two fields going to be empty. How do you identify whether this is by check, whether it is by credit card? Using another column called discriminator column. The column name is discriminator. What do you say? Discriminator. The discriminator will give you an idea which subclass has been used, whether it's a credit card subclass or check subclass. Okay. If you see the output, you can understand. So that is where I'm going to write. There is another column called discriminator. Okay. What is I'm going to call it as column, discriminator column. You don't have that discriminator column corresponding attribute in your payment object. In your payment object, whatever I'm going to write, it is not there. This is the dynamic value that will use to map the payment type. You can call it as anything. I'm going to call it as payment type. Okay. So type equal to string. Okay. So this payment is of type string. I'm going to convey that. Okay. So if this payment type, if it is by credit card, it will be credit. If it is by check, it will be by check. So that is what you need to convey here as well. What is the value for the discriminator? What is the value for this discriminator column? What is the value you want to insert for this discriminator? When you try to insert data through credit card, it will go as whatever the value provided, credit. Okay. When you try to do it for check, it will, you can say something like check. Okay. So that's it. Here we are done. So we configured here, we wrote the Pojo classes. Nice. We are trying for table per class scenario. And then we going for our client. This is where we were going to insert the data into the table. One small mistake we did is, I think so, yeah. This is payment is going to take payment ID and amount, right? But when you go for credit card, who is going to feed the amount for payment? Customer is going to provide the amount also, right? When you is trying for CCV number, customer also going to provide the amount. How do you populate that amount? So that is the reason you need to take another value, string. What is that? You can take it in the beginning also, no harm, right? Int payment ID. It doesn't use payment ID anyway, is not going to use because we are going to generate auto, right? And then another value, string amount. How do you pass these two values to payment card? How do you pass these two values to payment card? You can pass using super, right? You guys remember? Super using payment ID comma amount. So now if somebody try to pay amount by credit card, they are going to pass pay ID, amount, CVV, CC number, CVV. Anyways, payment ID we are not going to use because auto generation. Amount, CCC, credit card number and CVV will be available here. Amount is available in payment card. So payment card is a super class of credit card payment. So you are going to call it through super. So now if you call through super, it will go to payments of payment. So these values get initialized. Make sense? So same thing you need to do in check payment as well. Nice. Nice. Perfect. Here now what are you going to do? You're going to create as many objects as you want, as many payments, different payments, credit card, as many different users, credit card payments, as many different users, check payments you're going to create, right? So all you need to do is, how do you create? Credit card payment, CC1 equal to new credit card payment. You pass dummy value, amount is, I'll call it as 200. See, credit card number is, let me say 1 2 3 4 5 6 7 8 7 8 4 6 4 3 2 4. Okay, CVV is 3 3 2. Okay. Okay. So this is one object created now. Two second object, third object. Three objects of credit card I created, and I'll create two payment card check payments. CHE check payment. CHQ1 equal to new check payment. Sorry, new check payment, which will take all this value. I'll call it as one dumb value. Amount is some 229. Check number is 01132467889. And the check by Santosh. Okay, I'll do create multiple and I'll correct these values. Oh, sorry, why I copied this guy. Okay. What I am doing, I am just inserting the data. How we insert? If we have a inheritance concept, how the tables are going to create. I'm just modifying data. So we created 5 records, right? Now you want to do what? You want to save into database. How do we save? S dot save of cc1 cc2 cc3 chq1 chq2. Okay, done. So this time what will happen in the database? We will see what happens in the data, how many tables will be created, what you called yeah yeah, well, how many tables will be created and what happens we'll see inside. Okay, okay, we have as of now two tables, employee details and student. Let's see if you run the program what will happen. Please, if it doesn't fail. Unknown entity. Billing for Hibernate inheritance create card payment. Is there any naming problem? Oh, so what we did, one thing what we forgot, we forgot to configure the HBM file in configuration file. You got what I'm trying to say? We forgot to copy this guy. I mean, we forgot to include in configuration file. Configuration is the file which Hibernate understands and loads and parse it. We haven't added any payment related tables. Now it understands all the tables that has been there. So let's run again. Could not determine string a table payment for column payment type. It is not. Oh, tape is not string, just a string. Type it is. Not Java string. So let me run this. Awesome. So table created and inserted. Let's see how many tables created for our data. We created three different POJO objects, right? Check and credit card and payment. But how many tables created in the database? Let's see. It's created only one table. So let's see how many columns are there, whether our data is inserted properly or not, right? Let me open. Yeah. Select star from payment. Okay, HIV schema dot. See what happened? Try to understand. This is very important. So when you pay by credit card, amount, credit card number, CVV has been filled. Remaining values are null because you paid this time. Payment made by first three tables are payment made by credit card, but last two are payment made by check. So that is the reason credit card number CVV is empty. You getting my point? What I'm trying to say? This is, you can create as many objects as you want, like payments, credit card, check by, amount by, or mobile payments by, or online, web, different type of payments you can create. But if you want to go for table per class, only one table for across all the classes that you created, table per class. Here everything is considered as single class, not concrete class, it's saying class. Then this is how the table structure will be. Okay, so next option what we have, you guys got it? Table per concrete class. Table per concrete class. Okay, so how do you write table per subclass? All you wrote is like where is that, right? Yeah, this is what table per, all you did is subclass. You explicitly mentioned subclass and you conveyed the discriminator and corresponding discriminator value per subclass. Corresponding discriminator value per subclass you defined. So it will check if it is the amount is coming from credit card, then it will insert the payment type as credit. If the amount is coming from check, it will insert the payment type as check. Here credit, it's insert as check. Okay, nice. So another one that we're going to discuss about is, there are three different options that we have. You can do it whichever the one best fits for you. Okay, so I'm just copy pasting here. This time I'm going to show you table per concrete class instance. Now this time there will be a payment table, there will be a credit card payment table, there will be a check payment table, and the relation will be there in the database between these three. Okay, table per concrete class. What do we need to do? All you need to play around with this data here, whatever we have. So this piece you don't need to touch. Okay, so next piece is what you need to do. You don't need a discriminator in table per concrete class. You don't need a discriminator because you are going to have separate tables. Okay, this time this subclass becomes union subclass. Subclass becomes union subclass. In concrete class scenario, you don't need a discriminator because you're going to create a separate tables. For payment, you're going credit card, you're going to create separate table. For paycheck payment, you're going to create separate table, and payment also you're going to create a separate table. and this one becomes union subclass. When you use union subclass, which means you are asking for to create table per concrete class. But this time union class going to have what? Separate table, right? So you need to provide the separate table. This is a credit card table. See what will happen. And this is check table. So now you're going to create for check payment, you're going to create check table. Credit card payment, you're going to create credit card table. For payment, you're going to create payment table. Separate tables. Okay, that's it. You don't need to do any other changes. Let's see what happens. I think it should fail because of we have an update there. We need to have, because already table is there and blah blah blah, it will cry. One more thing, what we need to do, you need to inject this guy into Hibernate configuration file. This time you're going to insert configuration file, and just to avoid the clash, what I'm going to do, payment concrete. Concrete class. Otherwise, earlier payment table is there and it will fall into the clash and unnecessary headache. And I need to come back and delete that one. You can delete it, not a big deal. Just to keep all of them rather than deleting. Okay, let's run the program. Now see, we have only one table, right? Only payment table we have. Here in HIB schema, we have only three tables: employee details, payment, and student. This time it should create what? Three different tables. What are the three different tables name? Payment -concrete, credit card, check. Same class we are executing. Damn it. Syntax error near. Where is that? I think maybe I'm using because of this guy underscore amenities table names, right? Let me run the experiment. Okay, nice. So let me go and refresh what happens. See, now we got three tables: payment concrete, credit card, check, payment concrete. Three different tables. Got it? So how are they? Right? So CRET. This is created but not inserted. Yeah. So payment ID has been created. Mapping should be there. Why? Let me close it and reopen it. Maybe that is caching. Hmm. This is this is for table per subclass. So table per concrete class, right? But I am not sure why the data has not inserted in the payment ID. It's okay. For now, I'll look at it later. But at least we saw it, 3 tables created, and we need to see the data, right? MySQL. Select star from HIB schema dot credit underscore card. See, ID 123 200 656 434 different amounts, credit card, CVV number. You don't see check number, you don't see check amount. If you want to see check amount, check number, what you need to do? You need to call table called CQVV. So here 4 5. If you observe, right, so this one, it's very well maintained. 1 2 3 different tables, but unique ID has been properly maintained because payment card ID is coming from payment card ID and amount is coming from payment table, which will be same across 2 tables, check and credit card. That is the reason you will see there is no ambiguity. Getting my point? So how do you extract the data? Same way that we do it, that we tried with earlier style, like same method or criteria queries or HQL queries, whatever the way. Okay. So this is for what? Table per concrete class. There is another option that you can have is table per subclass. Okay. So everything is going to be same. No changes. All the changes that will happen is instead of union subclass, it is going to be joined subclass. Each table is going to be, when you mentioned joined subclass, it will be understood. It will be understood by Hibernate that you want table per subclass. But when you see subclass itself, why it is querying? Yeah, only thing is you need to do is foreign key, you need to insert key. What is the key value? What is the key? Column equal to payment underscore ID. Same thing, payment ID is, so this one I'm going to say sub check so that I can distinguish our existing tables, right? Sub underscore check, sub underscore credit card, sub underscore payment. Okay, 3 different tables. What else we need to do? Joint subclass is for what? Where am I modifying? Concrete class I am modifying. I should have modified here. I modified here. So I'll just rename this guy and it is. We're talking about what? Table per subclass now. When you are using subclass, you need to go with joined subclass tag. When you go for concrete class, you need to go for union subclass. When you go for simple per class, then you need to go for subclass. Don't get confused. Just try to the naming conventions. Okay, class table per class is you need to write the tags inside the simple class with subclasses, but table per concrete class is you need to write separate classes. You need to write separate classes. Okay, and subclass is you need to use joined subclass. Okay, let's see. So all you need to do is insert this guy into in CFG file. So and we'll see how many tables create. Same program. Okay, it inserted. So let's see first how many tables created. 6 tables existing. Now if I refresh, 9 tables. 3 tables are created. Sub check, sub credit card, sub payment. What are the values inside? Sub underscore payment, sub underscore credit, sub underscore check. See, in this time payment card is holding both ID and amount. In credit, how does this payment card and credit is mapping? What is sub underscore credit underscore card? It is mapping 3 columns this time. ID column also created. Same thing with check as well. ID column also created, and still it's going to have, so this is become primary ID. This is having both ID and same way that you created objects. You created 3 objects, 3 different objects. It's created 3 different objects. And this ID has been passed to credit card as well as check because that is unique across. Right? So table per, now tell me table per subclass, table per class is going to have single table. Table per concrete class, 3 tables. In our case 3 tables will be created. Table per subclass, 3 tables, and key in each subclass. If you look at earlier one, right, just to show you earlier one, what is that earlier one? Payment underscore concrete and check and credit, right? Select star from check HIB CHM schema dot CHEQB. This time, see, if you look at this check, this is what? I'll explain. This is what? table per concrete class. Check scenario I'm taking, and another one is table per subclass, and another one is table per from HIB schema dot table per class. So if you look at the table per class schema on solution, what is that? It's going to have everything in a single table. See, everything is going to have, if you have 10 subclasses, all are going to map here. But if you go for subclass, if I take one of the class, so both ID and check by. Where is the amount? Amount will be in payments table. Amount will be in payment table with the ID. So this ID and the ID check table ID will be mapped, and then identify the amount, right? But if it comes to concrete class, amount, ID and check and Santosh, both check by also will be there, right? So that those are the different, which one is better for you, you need to choose based on your requirement. You can achieve inheritance with a table per class, table per concrete class, table per subclass. You can achieve inheritance through those options. Make sense? Go back and look at these programs, you'll understand. Yep, that's it for today class. Tomorrow I'll take another class and finish it up Hibernate. Okay, thanks.